All right, we're going to begin our review video for section 4.8. That's chapter 4, section 8. It is, excuse me, as always, whenever we start a video, we start with our learning target for the day. Today's learning target is to graph dilations on a coordinate plane. Well, we need some definitions here, obviously. We need to know what a dilation is. We need to know what the center is, center of a dilation. We need to know what enlargement and reduction means. So let's get those terms down. A dilation is the transformation that results from the reduction or enlargement of an image. The center of the dilation is the fixed point used for measurement when altering the size of the figure. An enlargement is the dilation with a scale factor greater than 1, and a reduction is a dilation with a scale factor between 0 and 1. Well, let's jump in and do one here. The polygon PQRS on graph paper, and then draw the image of the figure after dilation with the center at S by a scale factor of 1/2. So if I look at the point S compared to P, I look at this line. This line right here is 1, 2, 3, 4 units long. So if I'm going by a scale factor of 1/2, that means that to P prime will be half that distance, or only 2. So that's P prime. If I look at Q is up 1, 2, 3, 4, and over 1, 2, 1, 2. So Q prime would be just over 1 and up 2. So this is Q prime. Right? R is 1, 2, 3, 4, 5, 6 units over. So it's 1, 2, 3 over 2R prime. And that becomes my dilation with a scale factor of 1/2. Notice that the lengths of each of the sides is half the lengths in the original drawing. Here's another one. Copy the polygon ABCD on graph paper, then draw the image of the figure after the dilation with center A and a scale factor of 2. If this is a center factor as A, and it's 1, 2, 3, that means that the distance on the dilation is going to be twice that, so it's going to be 1, 2, 3, 4, 5, 6, so that would become B prime. C is over here 1 unit, 2 units, and up 2, so it's 2, 2. If I have a scale factor of 2 over 1, I take each of those times 2 over 1, which would give me a factor of, or a point of 4, 4. So it's 1, 2, 3, 4, 1, 2, 3, 4. So it's right here. So I have the 2 points labeled, C prime, B prime, and C prime. D is over 1, 2, and if I'm going to multiply, so that is a factor of 2, 0. If I take that times 2 over 1, it would become 4 over 0, or 4, 0. So it's 1, 2, 3, 4. And my figure becomes, becomes like that. All right, so if I look over here to see which one of those drawings has that kind of a shape to it, it looks maybe it's going to be D. I've got to check. 1, 2, 3, 4, 5, 6. So that part checks out. C would be 1, 2, 3, C prime rather. 1, 2, 3, 4, 1, 2, 3, 4. So C prime checks out, D checks out. So D is my correct answer on this one. Another one here, we're asked to graph the triangle MNO with those vertices. So let's do that part first before we even get into it. 3, 1. So let's go 3, 1, 1, 2, 3, and up 1. So this is the point M. I'm sorry, I did that wrong. It is 3, negative 1. So it's 1, 2, 3, and negative 1. So this is M, point M. 2, negative 2, 1, 2, and negative 2. That point is N. And the last point here is 0, 4, 0 and 4, 1, 2, 3, 4. And that point is labeled O. So here's my shape. That's my original shape. Now I'm asked to then do a scale factor here of 2/3. That means I take each of the ordered pair and times 2/3. So I've got 3 comma negative 1 times 3 halves. So 3 halves times 3 would become 9 halves, comma 3 halves times negative 1 would become a negative 3 halves. That's my first ordered pair, so let's graph that one. 9 halves would be about 4.5. So that's 1, 2, 3, 4 and a half, and negative 1.5 would be about right there, and that would be point M prime. All right. The next one, 2 comma negative 2 times 3 halves. This 3 halves times 2 would become 3. 3 halves times negative 2 would become negative 3. So 3, negative 3. 1, 2, 3, 1, 2, 3. This is point N prime. And the last one that we have to calculate was the point 0, 4. So 0, 4 times 3 halves. Well, 3 halves times 0 is still 0. 3 halves times 4 would be 12 halves, or simply 6. So 0, 6, 0, 1, 2, 3, 4, 5, and 6 would be up here. As I connect those dots, then the red lines become my dilation with a factor of 3 halves. Graph triangle JKL with vertices at 2, negative 4. I'm sorry, 2, positive 4. 1, 2, positive 4. So this is J. At 4, 6. 1, 2, 3, 4. 1, 2. I'm sorry. 4, negative 6. 1, 2, 3, 4, 5, 6. And 0, negative 4. 0 and negative 4 is right here. So that's the graph of our triangle JKL. And we're asked to then graph its image of J prime, K prime, L prime with a scale factor of 1/2. Well, I can take 1/2 times 2 comma 4. So 1/2 times 2 is 1. 1/2 times 4 is 2. So the first point I need to plot is 1, 4. 1, 2. I'm going to switch colors here. 1, 2. And the next one then would be 4, negative 6 times again 1/2. So 1/2 times 4 becomes 2. 1/2 times negative 6 becomes negative 3. So I've got to graph the point 2, negative 3. 1, 2, 1, 2, 3. So I have 2 of the points so far. The third point here is 0, negative 4. Also take that times 1/2. Well, 1/2 times 0 is 0. 1/2 times negative 4 is negative 2. So I've got to plot the point 0, negative 2. 0, negative 2 is right here. And the green lines then become my dilation with a scale factor of 1/2. All right, now in this case, we're given the 2 line segments, the line segment X and X to Y, x to y and its dilation of x prime to y prime, and we're asked to calculate the scale factor. Well, if I look at x, the points here is 1, 2, 3, 4, so it's negative 4, comma, 1, 2. That's x. If I look at x prime, it's 1, 2, 1, negative 2, comma, 1. I'm going to look at my ratio here, and I'm going to say, well, negative 2 is to negative 4. I'm going to reduce that ratio or that proportion to 1/2. So the scale factor in this case is 1/2. I could check for y up here, and I could say that y is 1, 2, 1, 2, 3, 4, 5, 6. So it's 2, comma 6. And I check for y prime, it's 1, 1, 2, 3. And if I set up the same kind of ratio this time between either the x's or the y's, I could say it's 1 over 2 or 3 over 6. They both reduce to 1/2. So my scale factor in this case is exactly 1/2. We're asked to do the same thing here. Please do this on your own and then come back and check the video to see if you're correct. Here is the original drawing, A, B. The dilation is A prime, B prime. So the ordered pair for A is negative 2, comma 1. And the drawing for A prime is negative 1, 2, 3, 4, negative 4, comma 1, 2. If I set up a ratio between the the A prime for the x values, which would be 4, negative 4, over the x value for the A, it's negative 2. 4 over 2, the negatives cancel, I'm left with 2. So I've got a scale factor of 2, and it is an enlargement. So my answer here is B. We could check by doing that with the B point if we wanted to, but I'm very confident the answer would come out to be the same. Here's another example. The pupil of Josh's eye is 6 millimeters in diameter. So the pupil of his eye, 6 millimeters is its original dimension. His doctor uses a medicine to dilate his eye by a factor of 3/2. Find the new diameter. Well, 6 millimeters times the dilation factor or scale factor of 3/2 is 6 over 1 times 3 over 2. I can do some reducing here. 2 will go in there once, 2 will go in there 3 times 3 times 3 would be 9. 9 millimeters is the new dimension, the dilated dimension. Here's another problem. So it's very similar. Please do this one on your own and then come back and check with the video to see if it's correct. The eyes start out at 8 millimeters. So 8 millimeters times the scale factor of 3/2. So 8 over 1 times 3 over 2, I can do some reducing. This would be 1, this would be 4. 4 times 3 would be 12. 12 millimeters is the new dilation, which happens to be answer C.